This lecture is on my PC's internet setup. And the focus here is to understand the internet connection and the operations of TCP IP through the computer that you always use to connect to the internet. When you look into the control panel, you can see the networking and sharing center listed down there. If you click on it, you'll be able to go and control the configuration that connects you to the internet. Now, I'm using a Windows-based operating system on this computer that I used to prepare this lecture. In case you're using a different type of computer that has a different operating system, then the interface to the control panel for internet setup is going to be a little bit different. However, the basic values and the way to set it up is actually the same. So therefore, if you look through it a little bit and listen to this lecture, you'll be able to know exactly what and how to do things the right way. Now, if you click on the networking and sharing center icon down there, you'll be able to see the network connection inside. And here is the Ethernet connection that you see. If you click on that, you'll be able to get the window over there. Now, on that side, you can look at the internet connection, which has the TCP and IPv4. It's already selected in blue. If you go and click that, then the window that you see right here opens up. Now, in this window, the option on the top here is the DHCP, which is this right here, the Dynamic Host Configuration Protocol. Now, we're going to study about that in the next lecture. But first, we're going to go into the manual mode correction control mode, which is listed down here. So, I'm going to go and select this and actually look at how these values right here are actually set up and what they mean to your connection of the PC to the internet. Now, let's look at the IP address first. The PC's internet interface IP address is 165.132.126.159. And as you can see, the IPv4 32-bit address is listed here in decimal numbers. Actually, if you look at it, it's listed in binary numbers that were converted to these decimal numbers. Now, the 32-bit address is a combination of 4 bytes, and each byte is 8 bits. In addition, 1 byte is also called 1 octet. So a byte and an octet are the same thing. They are each 8 bits each. Now, an IPv4 address is 32 bits, which is 4 bytes. So basically, with 8 bits, you can represent a number from all 8 zeros to all 8 ones. And therefore, the number would range from 0 to 255. Then, what the address does is that it has 1 byte and then a period, 1 byte and then a period, another byte and then a period, and the last byte. So therefore, you have 4 bytes, which are 4 bytes equals 32 bits of the entire IPv4 address. So therefore, if you were to look at the IP address assignment here, then basically, as you can see, the 165.132.126.159 would map into the binary sequence of what you see right here. And this is a binary form. And this is how we represent the IPv4 address. IP addresses are assigned to each interface. And a computer or a smartphone may have multiple interfaces, and therefore they will need multiple IP address assignments. Basically, one IP address for each interface is required. For example, I'm going to look at a smartphone here that you see, which is a Samsung Galaxy S7 Edge device. If you were to look into this device, basically it has multiple interfaces. For example, for mobile communication, it has a 2G, a 3G, and a 4G connection for mobile communication. In addition, for Wi-Fi, it has the other connections, which are basically for the IEEE 802.11 A, B, G, N, and AC modes. And these support the 2.4 and 5 gigahertz frequency ranges. In addition, for Bluetooth, 4.2 is also on this mobile device. So therefore, each of the interfaces need a separate IP address. And that's why a single device can consume a lot of IP addresses in order to support all of its connectivity. Now, subnet mask. The internet is divided into subnets. These are subdivisions of the overall internet, and they divide it this way so that the networks are groups that are managed together, and it helps the routing to be much more efficient and scalable. So therefore, if you look at it, the internet is divided into subnets, and subnets are divided into smaller subnets within. A subnet mask is based on the size of the subnet that the client, the PC, is connected to. An IPv4 subnet mask is formed by 32 bits, just the same length as its IP address. And you have ones or zeros in a sequence from left to right, from the left MSB to the right LSB. MSB stands for most significant bit. The LSB stands for the least significant bit. Now, the subnet mask is used to filter the IP address such that you can easily determine if this packet belongs to this subnet or not. For example, let's look at this window down here, and it has a subnet mask. The number that you see is listed above here. It is 255.255.252.0. Change that into binary, and this is what you have. Here, you can see the series of all the ones, and then you can see the zeros right here. There are 10 zeros right in a sequence. Now, the subnet mask can be used to find the subnet size. In this example, we have 10 zeros down here, so therefore 2 to the power of 10 equals 1024. So in this subnet, there are 1024 IP addresses included in. Now, but not all IP addresses are going to be used for individual PCs. Some of them are actually may be used for the internet connection itself, as well as some actually may not be used. They may be reserved for future use, and if they are not used in the future, well, then they're going to be wasted. Now, we'll look into this issue a little bit later in this chapter when we go into actual IP subnetting of our own, and we solve a problem to set up the routing table. The details are in there, so just wait a little bit. Next, we're going to look into this part, which is the default gateway. The default gateway address is listed down there. The default gateway is the dedicated internet router that will send and receive all internet packets for this PC. So basically, if you know your PC the way it's set up, in addition, if you know how your default gateway is set up, basically your connection to the internet is exclusively explained all of its functions through this. So therefore, knowing this makes you very powerful when it comes down to your TCP IP knowledge. So therefore, that's the focus of this chapter, and we'll get deeper into it. Now, as you can see, the PC will access the internet through this gateway. All packets that is sent and received at this PC is going to go through that gateway. That is why it's called the default gateway. It's default. And by definition, all gateways are IP routers. So that's why you're going to see me use the word router and gateway interchangeably. Okay? In the window over here, you can see that use the following DNS server address. And there is a preferred DNS server and an alternate DNS server IP address. What do these do? DNS stands for Domain Name Server, and it's a server that converts host names into IP addresses. A host name example would be for like if you're an email user that uses Gmail, then the ID, your email ID with @gmail.com. Then the gmail.com would be the host name. For a website example, well, www.facebook.com. Then that facebook.com would be the host name. DNS operates this way. It converts the www.facebook.com into an IP address. Now, we need the IP address in order to route the packet to the server such that the server can respond back with the information that we want. Now, as I just explained, there is a preferred DNS server which is the main one, and then there's a alternate DNS server, which is the backup one. And these two support your connectivity by changing domain names into IP addresses.